Hello everyone and welcome to this comprehensive introduction to descriptive statistics, which is our focus in today's lecture. So think about it this way. Every day we have data coming in from everywhere. For example, Netflix knows what shows you like, your bank knows your spending pattern, colleges know your test scores. But then the thing is, raw data by itself is almost meaningless. So if we give you 500 test scores at you right now, just a bunch of numbers, what would you understand from it? Probably not much. So descriptive statistics is a toolkit that transforms that meaningless jumble into something we can actually understand and communicate to others. So what is exactly descriptive statistics? Simply put, descriptive statistics are used by researchers to report on populations and samples. In sociology specifically, and this applies across the social sciences, we use summary descriptive statistics as measurements, or what we call variables, taken about groups of people. By summarizing information through descriptive statistics, we speed up and simplify comprehension of a group characteristics. That's really the heart of it. We're trying to take complex information and make it simple, clear, and understandable. Let's first differentiate between a sample and the population. So we need to establish this very important distinction between the two. So a population is the entire group we're interested in studying. If you're a researcher studying college students' mental health, for example, your population might be all college students in the United States. That's millions of people. If you're a sociologist studying voting behavior in San Jose, your population is all registered voters in San Jose. A sample, on the other hand, is a subset of the population. You take a portion of the population, say 500 college students or 200 registered voters, and you study that group instead. So why would we do that? Because studying the entire population is usually impossible, or too expensive, or is going to take too long. Now, this is a very important detail here, is that the descriptive statistics that we're going to calculate from samples are going to look slightly different from those we calculate from an entire population. We actually will use different formulas. This matters, and we'll talk about why as we go deeper into the material. But for now, just remember, descriptive statistics work with both populations and samples, but the calculations will slightly differ depending on what you're working with. So let's see why descriptive statistics matters in the context of a concrete example. Imagine you're an administrator at a school and you want to know which of two classes is smarter. Okay, so that's a question we need to answer. You have class A, we're giving you IQ test to both classes, and then we give you results from both of them. So class A has 13 students, and you can see their IQs here. And class B has also 13 students, and you can see their IQs. Now, if I asked you right now which class is smarter, what would you say? Well, it's not clear, right? You're trying to hold 26 numbers in your head and compare them. So this is the fundamental problem descriptive statistics tries to solve. Each individual might be different. If you try to understand a group by remembering the qualities of each member, you will probably fail to understand the group as a whole, and that's why descriptive statistic comes in. when you look at this specific examples, if we get the average IQ, for example, for both group, we almost get the same number. Okay, so with the summary descriptive statistics, it's much easier to answer the question and determine that there's not statistically, what we will call later statistically significant difference between the two groups. So what are the different types of descriptive statistics? We can organize data in tables or graphs, and we can also summarize data through measures of central tendency and measures of variability or variation. So tables will include frequency distributions, relative frequency distributions, and a graph will include bar charts or histogram, stem and leaf plot, and frequency polygons. So then the first thing we do with the data is to organize it. So in a frequency distribution is essentially the most basic type of table. A frequency distribution just shows you how many times each value appears in the data set. So for example, if we look at the IQ data, if we create a frequency distribution of both classes combined, we will see something like an IQ of 82 appears twice, for example, 87 appears once, 89 appears once, and so on. This is helpful because it immediately shows us which IQ scores are most common and which one are more rare. Now, sometimes a simple frequency distribution is not enough. So we also create what's called a relative frequency distribution. So a relative frequency distribution will show us percentages instead of counts. So instead of saying an IQ of 93 appears twice, as you can see in the table, we can say that an IQ of 93 appears in 8.3% of the cases. This is particularly useful when comparing groups of different sizes. So we can even group the data to make it even cleaner. Instead of listing every single IQ score, we might group them into ranges, like score between 80 to 89, 90 to 99, and so on. Okay, this is called a grouped frequency distribution, and it takes patterns. It makes patterns much easier to see. So now tables are great, but sometimes a picture is really worth 1,000 words. So we use graph also to visualize data. So the most common graph is a histogram, which looks like a bar chart. You put the variable on the horizontal axis. So in this case, it's IQ scores, and the frequency on the vertical axis, and you draw bars showing how many people fall into each range. When you look at the histogram, patterns can be seen immediately. We also use bar graphs for categorical data, stem and leaf plots for showing the actual distribution of individual values, and frequency polygons, which connect the points with lines instead of showing bars. Each one will have its application. So this is a histogram for the two classes. This is a bar graph showing the number of students in each class, class 1 and class 2. You can see that they each have 12 students. This is a stem and leaf plot for the two classes. And you can also create what's called a frequency polygon, which is similar to the histogram, except instead of using bar charts, it's using a line plot by connecting the points. Now, Let's look now at descriptive statistics, how we summarize data. So one way to do this is by finding the middle or the most typical value. We call these measures of central tendency. And there are three main ones: the mean, the median, and the mode.